Whether you are a curious beginner, a student starting out, or a future inventor, you are in the right place. Today, we are starting something exciting, a two-part series on electronic components and how they are used in the real world. In this first part, we will break down the basic building blocks of electronics like resistors, capacitors, diodes, and transistors, and explain what they do in a simple and visual way. By the end of this series, you will be able to recognize components in gadgets, understanding what makes them tick, and even start building your own simple circuits. So grab your breadboard or just a notebook and let's begin this electrifying journey into the world of electronics. Let's start at the beginning. What exactly is an electronic circuit? An electronic circuit is a closed path that allows electricity to flow. It's the foundation of every electronic device you have ever used, from your phone to your fan. Think of an electronic circuit like a road traffic system. The battery is your fuel station. It supplies energy to get everything moving. Wires are like roads. They guide the flow of electricity just like roads guide cars. Resistors are the speed breakers. They slow down the flow to protect sensitive parts of the circuit. LEDs are streetlights. They lighting up when electricity flows through them. Switches act like traffic signals. They control when and where the electricity should go. And just like cars eventually loop back to the fuel station to refuel, in a circuit, the flow of electricity returns to the battery to completing the loop. So every component in a circuit plays a role. Some components control the current and some storing energy. And few components act like switches and few more react to the environment, like detecting light, heat, or motion, just like a well organized traffic system. Understanding how these parts connect and work together is like learning the alphabet of electronics. Once you get it, you can start wiring and writing your own sentences. From blinking LED to a smart home sensor. It's really that powerful. First up, resistors. These are probably the most common components you will find. A resistor job is very simple. It limits or controls the amount of current flowing through a circuit. Why is that important? Well, imagine you are sending water to a garden. Without a flow restrictor, the water might come out too fast and destroy your plants. Resistors do the same thing for electricity. They protect other components. One classic example, when you connect an LED to a battery, you need a resistor to prevent it from burning out. LEDs are sensitive and too much current will destroy them. Resistors are rated in ohms, a measure of how much resistance they offer. Ohm's law connects voltage, current, and resistance in a neat form. And yes, that's something you will hear a lot in electronics. Resistors also help divide voltage in circuits, like splitting a power line into smaller levels for sensors or chips. So, next time you see those stripped cylinders, you will know they are quite. Next up, capacitors. Capacitors don't resist flow. They store electrical energy for a short time, then release it when needed. Think of them as mini rechargeable tanks. You will find them in almost every power supply. When you turn on a device, capacitors smooth out the voltage so things don't flicker or shut off. Want a real world example? Look at a fan. Sometimes it spins for a second even after you turn it off. That's a capacitor at work slowly discharging. Capacitors are come in different shapes and sizes. Some are tiny for signal filtering, others are big and bulky, like those in a computer power supply. You can also use capacitors in timing circuits. For example, you can make an LED blink every few seconds using a capacitor and a resistor. So, whether you are building a robot or repairing a speaker, capacitors are essential energy managers in your toolkit. Now, let's talk about the third major passive component, the inductor. An inductor is just a coil of wire, but it has a very interesting ability. When current flows through it, it creates a magnetic field. If the current changes suddenly, the inductor resists that change. It stores energy in its magnetic field and releases it gradually. Imagine water flowing through a hose. If you suddenly turn off the tap, the water does not stop instantly. It keeps moving due to pressure. That's what inductors do with electricity. You will find inductors in power supplies, radio circuits, and anything involving magnetism like transformers. They are often used to block high frequency noise or to smooth out power in circuits, similar to capacitors, but they respond differently. Inductors aren't as common as resistors or capacitors in beginner projects, but they're absolutely essential in advanced electronics. Let's move on to active components. First up, diodes. A diode is like a one-way street for electricity. It allows current to flow in only one direction and blocks it in another direction. Why does that matter? Well, in many electronic circuits, the direction of the current matters a lot. If current flows in the wrong way, it can damage sensitive parts. A very common use of diodes is in power supplies, like the charger for your phone. Diodes make sure that the electricity flows correctly into your device, protecting it from damage. There is a special kind of diode called light emitting diode or LED, which lights up when current flows through it. That's why you always see LEDs connected in a specific direction. Another demo you can try, reverse a diode in a circuit with an LED. If it's backwards, the LED won't light up. That's the proof that diode is blocking current. Diodes are simple but powerful. You'll find them in rectifiers, voltage protection circuits, and logic gates. Definitely a key tool in your electronic toolbox. Next up, transistors. These tiny components are everywhere in your phone, your computer, even inside your washing machine. Transistors have two main jobs. They can act as switches or amplifiers. Let's talk about switching first. Imagine a transistor as a remote control switch. When you send a small signal to its base pin, it allows a larger current to flow between the other two pins. Those are collector and emitter. In a basic LED circuit, you can use a transistor to turn the LED on or off with just a tiny signal. This is how microcontrollers control things like lights and motors. Now, second application, amplification. When used this way, transistors can take a weak signal like your voice from a microphone and boost it enough to drive speakers. Transistors comes in many types, NPN, PNP, and MOSFETs, each with its specialty. Learning them unlocks so many projects. Last in this section, ICs or integrated circuits. An IC is a complete circuit miniatured into a tiny black chip. It might contain hundreds, thousands, or even millions of transistors and components inside. ICs handle specific tasks: timing, processing, amplification, motor control. These are all depending on their design. Take the 555 timer chip for example. It's one of the most famous ICs, used to make LEDs blink, generate tons, or even more simple robots. Another example, the Atmega 328P. chip inside an Arduino board. That's an entire computer on a chip, able to read sensors, make decisions, and control devices. ICs are the brains of the most electronics today. Smartphones have dozens of them working together. Even a microwave has several ICs for timing, sensing, and displaying control. So, when you see a black chip with many legs, you are looking at a powerful little circuit ready to help your project come to life. Input components are how we or the environment communicate with a circuit. Let's start with the simplest switches and push buttons. A switch either connects or breaks the flow of current. It's like opening or closing a door. Push buttons work the same, but only while you are pressing them. When released, they open the circuit again. You will see switches used to turn things on or off, like a flashlight, and push buttons in calculators, keyboards, or gaming controllers. You can use them to trigger an LED, start a motor, or even send a signal to microcontroller to do something cool. Try wiring a push button to your Arduino. It's the simplest way to get interactive. Now, let's look at smart inputs, sensors. Sensors detect changes in the environment and turn them into electrical signals. Let's talk about two simple ones, the LDR and the temperature sensor. LDR stands for light dependent resistor. It changes the resistance based on the light levels. In bright light, resistance drops. In darkness, it increases. You can use this to turn on lights automatically at night. A basic demo. Connect an LDR and an LED in a circuit. Shine a torch. The LED turn off. Cover it, the LED lights up. Now, temperature sensors like LM35 changes voltage as the temperature rises. These are used in thermostats, smart fans, and even food process. Sensors open up a whole world. You can build smart lighting, automatic fans, and even weather stations. Finally, let's talk about the outputs. The components that do something visible or audible in a circuit. First up, LEDs. We have seen them before. They light up, blink, or indicate status in almost every device. Buzzers make sound from beeps to alarms. They are great for alerts or audio feedback in games and tools. Motors turn electrical energy into motion. You will find DC motors in toys, fans, and robots. Even tiny vibration motors in phones. All of these can be controlled directly or through microcontrollers. With some clever wiring, you can make lights flash in patterns. Motors move back and forth, or buzzers play tunes. Outputs bring your circuits to life. Alright, we have learned what all these components do. But the big question is, where do you actually see them in action? Let's take a walk through some of the devices and systems you use every single day and break them down component by component. Let's begin with the smartphone, the device you probably have in your hand right now. Inside that sleek frame, there is a complex web of integrated ICs, transistors, resistors, capacitors, and many more. The touchscreen, it works using capacitive sensing, detecting the tiny changes in electrical charge when you finger touch it. The sound system uses amplifiers built using transistors and op amps. The camera has an image sensor and high-speed data processors. And don't forget that LEDs for screen, backlighting, flash, and notifications. Your smartphone is a live example of electronics working in a harmony every second. Now, let's go from smart to study. Think about your washing machine. You toss clothes in, press a few buttons, and boom, it washes, rinses, spins all by itself. But what's happening inside? There are relays to switch powerful motors on and off. Timers and microcontrollers run the program that determines how long each cycle lasts. Temperature sensors check if the water is warm enough or not. And diodes protect sensitive parts from voltage spikes. Even the display and buttons use resistors, capacitors, and LEDs. What seems like a simple appliance is actually a well-designed electronic system. Let's move on to smarter space, the modern smart home. This is where things get really exciting. Using microcontrollers like ESP32 or Arduino, we can control everything from lights, fans to door locks and alarms. We have motion sensors to detect when you walk into the room. LEDs are there to help automatically turn the lights on or off when it gets dark. Temperature sensors are there to adjust the air conditioning or heating. And everything is connected, often wirelessly, to a central hub on your smartphone. These systems run on exactly the same components you are learning, just connected in a clever way. Now imagine building something yourself, like a simple robot. In robotics, you will use just about every type of component we have talked about. You will need motors to move, sensors to see or detect obstacles, microcontrollers to make decisions, and power circuits to fuel it all. Want your robot to follow a line. To design a line follow robot, you want an IR sensors. If the robot need to avoid the obstacles, you have to use ultrasonic sensors. Robotics is a playground for experimenting with electronics, and it makes learning incredibly fun and practical. And don't forget about something as everyday as a power bank. Inside, you have got a lithium ion cells to store energy. Protection circuits made of diodes and MOSFETs to prevent overcharging or short circuit. Capacitors are there to smooth the voltage output and USB control ICs that manage power delivery. Even the LED indicators that shows how much battery is left use basic components like resistors and LEDs. You want a simple example? Just grab a modern LED bulb. Even though it seems basic, it contains a driver circuit that converts AC to DC. It regulates voltage and controls the current flow using resistors, capacitors, bridge rectifiers, and sometimes even tiny ICs. It's not just a bulb, it's a mini power conversion system packed into a small shell. These real world examples show us something important. Learning electronics isn't just about theory or textbooks. It's all about understanding how the technology behind our favorite gadgets actually work. And once you start recognizing components in everyday life, you will never look at the device the same way again. So, how do you start your journey? Here are the 5 solid steps. Get a beginner electronics kit with resistors, LEDs, sensors, and a breadboard. Watch YouTube tutorials and experiment alongside with us. Use online simulators like Tinkercad or Proteus to build circuit virtually. Read datasheets to understand how each component works. Build small projects like blinking LEDs, light decorators, buzzers, or fan controllers. You don't need expensive tools to begin, just curiosity and the willingness to try. Remember, every expert you see once struggled with their first circuit. Keep tinkering. And that's a wrap up on part 1 of our deep dive into electronic components and how they are used in real life. In part 2, we will explore more advanced sensors, modules, displays, and microcontroller basics. So make sure you don't miss it.